guys, hi, welcome to my channel.
As a designer, let's try to find the ways to get the speed of the aircraft close to Mach 1 without encountering the large drag rise. There are two options to delay the drag divergence to a high Mach number. First is design the airfoil thin, but however, there is a limit to how thin a practical airfoil can be. For instance, the airfoil requires a certain thickness for structural strength, and also there must be room for the storage of the fuel. But this arises a question: for an airfoil of given thickness, how can we delay large drag rise to high Mach number? So one of the option is, let's try to increase the Mach number increment between the critical Mach number and the drag divergence Mach number, which can be done by adopting a specially shaped airfoil called as supercritical airfoil. So the supercritical airfoil is different approach to increase the drag divergence Mach number. The shape of the airfoil is designed with a relatively flat surface, since it is designed with a flat suction surface or the upper surface, which is covering around the 60% of the forward airfoil, that is from the leading edge, so as to have a moderate suction peak, meaning it is having a negative camber near the leading edge. An actual supercritical airfoil combines the effect of the rearward loading, peaky distribution, and flat surface pressure distribution over the top surface. It has a relatively high leading edge radius, which allows reductions of the curvature of midchord regions of both upper and the lower surfaces. The extent of the flat zone of the upper surface is restricted to avoid the flow suppression, which is further compensated by having a cusp or a concave like shape of the bottom surface near the trailing edge, resulting in a positive camber on the rearward 30% of the airfoil towards the trailing edge. Also, we can notice that the trailing edge is thick not only for the structural purposes but also to improve the high-speed aerodynamic characteristics. So to further understand the flow physics of the supercritical airfoil, let's try to compare it with the flow physics of normal airfoils to have a better understanding about the flow physics of the supercritical airfoil. So in case of the normal airfoils, they generate a strong shock wave at the middle of the chord, which is more intense as the fluid accelerates the downstream of the crust. The shock wave tends to become more intense, and also at the downstream of the shock wave there is an adverse pressure gradient, and due to this adverse pressure gradient the boundary layer tends to detach, which is further increasing the amount of the drag. But whereas in case of the supercritical airfoil, the point where the shock wave is formed is behind the middle point of the chord. So the surface pressure distribution at the leading edge has a peak with a localized minimum pressure, and rest of the surface pressure distribution over the top surface is reasonably uniform, so the fluid does not accelerate, and a gradual deceleration will occur, and the shock wave that generates is not strong. A uniform pressure distribution rearward of the shock wave allows the boundary layer to be re-energized by the external flow before it comes in contact with the adverse pressure gradient near the trailing edge. So as a result, the boundary layer can move through a greater pressure rise without separating. So the disadvantages of the supercritical airfoil is that it is having a bad low speed behavior. So as there is a suction peak in the leading edge, while reducing the speed of the aircraft and at higher angle of attack, the adverse pressure gradient just downstream, the suction peak becomes higher, increasing the probability of a stalled airfoil.
The aim, in fact, is to avoid the formation of the strong shock wave, and this is why the value of drag divergence Mach number will be higher for the supercritical airfoil. So the first aircraft that used the test supercritical wing design was modified by FS Crusader provided by the US Navy, and these are the few of the airplanes on which the supercritical airfoil has been implemented. So this is why it is essential to have a supercritical airfoil into your design. Thank you.